Hello everyone, and thanks for joining us for today's webcast, Getting the Most Out of Your Data Lake. My name is Alaistair Jones, and I'm a Business Intelligence and Analytics Consultant at Thorogood. I'm joined today in our Philadelphia office by my colleague, Ben Dunmire. Before we get started, I wanted to begin by outlining some objectives for today's presentation. So firstly, there are different conceptions of what a data lake is, and it can be quite a broad topic. So we're seeking to level set on what we think of when we say data lake, and then run through some common reasons why enterprise organizations are interested in adopting this technology. We're also seeking to provide the audience with a concrete data lake use case or use cases and an overview of technical implementations in order to provide more tangible examples of drivers for adoption and to highlight how varied data lake implementations can be. And finally, we're going to conclude today by outlining how enterprise organizations can begin to get started considering or undertaking a data lake implementation. So here is today's agenda, and it kind of mirrors these objectives. So we're going to start with an introduction to Thorogood before providing a definition of data lake and relaying some of the drivers that we're seeing our customers citing as reasons for investigating and implementing data lakes. We'll walk through some case studies of specific data lake initiatives that we've been involved with, and then we'll wrap up with considerations for getting started with data lakes. So for those of you who don't know Thorogood, we're an independent global professional services firm specializing in business intelligence and analytics strategies, solutions, and services with a keen focus on our customers. In all of our engagements, we seek to blend an understanding of the business goals with a strong grounding and knowledge of the technical possibilities to create optimal solutions for our customers. We're a global company with offices in London, New York, Philadelphia, Singapore, Sao Paulo, and Bangalore. We offer a full range of BI and analytics services, including strategy and roadmaps, requirement, design, implementation, and training and support. Our focus on the business goals and our expertise in the business intelligence domain makes us well placed to understand the unique and differing needs of enterprise organizations when they investigate the potential of data lakes and help them select and implement the tool and architecture that makes the most sense to meet these needs. Our clients typically span 4 data-rich verticals: consumer goods, pharmaceutical, and health services, banking, and insurance. Our clients are some of the leading organizations in these sectors, and we take a lot of pride in the long-standing relationships we've fostered with some of the names that you see here. Our clients are large, complex businesses, and we rely on our thorough business understanding and deep technical expertise to deliver successful solutions to their business challenges. So with regards to data lake considerations, each one of these organizations originates its own data, receives data from vendors and partners, and utilizes market data and external data that all need to be incorporated for best effect. We're independent in that we don't align with a single technology vendor. Instead, we work with a wide array of technology firms in the business intelligence market, including back-end, front-end, and analytics-driven technologies. Our technology independence and knowledge spanning the front to the back end of the BI stack allows us to determine optimal data lake design patterns for customers that we work with. So we'll get started by now providing a high-level overview of data lakes, their purpose and their role in a modern BI stack, and reasons why we see Thorogood customers adopting them. So I'm going to start off by addressing some of the various reasons we're seeing enterprise organizations that we work and partner with begin to explore or invest in data lakes. So to start with, users are empowered with a wide array of data at their disposal with data lakes, and they can analyze this data in their tool of choice. A data lake enables data scientists to explore use cases by providing access to any enterprise data securely and at the right level of detail, and allows analysts to connect to a variety of unaligned and volatile data sets to produce recurring or ad hoc insights. By consolidating a vast amount of data in one place, the data lake provides a complete view of the organization. Consumers of this data can gain a holistic picture of areas of their business and understand history, trends, potential opportunities, and risks by gaining insights from various internal data sets as well as external data sets that have been made available. A data lake provides the ability to quickly ingest and align external data to determine if there's business value in storing and reporting on it. This agility and ability to quickly load and access data is valuable to businesses in an increasingly competitive landscape. The data lake offers an organization the ability to operate existing systems with reasonable data volumes, such as long-standing data warehouses, or retaining access to a large volume of historical data in the lake. So older data may be valuable in the future, but take too much of a performance hit or cost too much to keep stored in the traditional data store. So cheap data lakes storage is valuable to keep this data retained as an asset for potential future use. Data lakes can store and catalog various types of data, not just column-oriented structured data. This allows analysts and data scientists to gain new insights from unstructured or semi-structured data sources that were previously unable to be accessed and integrated alongside more traditional data. This can include everything from less structured files produced by business users to images, emails, video, or audio that has been captured and recorded. There is a large amount of untapped potential from these new types of data sources. The data lake enables capture of near real-time data, such as streaming data or transactional data, changing from one or more data sources. There is an increasing amount of data available for businesses to track, and increasingly this data is becoming real-time in nature. A data lake promotes data discovery, as the organization can begin to collect and retain data with speculative value for the purpose of analytical insights at some point in the future. They have the ability to identify new relationships or trends from data sources that have never been related. What were once relatively standalone data sources maintained and utilized by different parts of the business can be potentially viewed side by side and then combined for analysis. And fundamentally, the data lake also helps to promote self-service reporting and analysis with the flexibility to support different BI use cases. Analysts and data scientists can access cuts of organizational data that they need for their own purposes. So these are just a handful of the common business drivers that we've seen our customers consider when deciding to adopt a data lake as part of their data architecture and landscape. There are, of course, many other factors that contribute to an organization's decision on whether to invest in a data lake. A key point is that the way that you design your data lake and the architecture surrounding it varies greatly based on the distinct set of business drivers that are leading you to adopt that tool. So what is a data lake? Fundamentally, a data lake is a storage repository that holds large volumes of data in a variety of formats, structured, semi-structured, or unstructured, and can retrieve data on demand. So what do we mean by each classification of data that I just mentioned? Well, structured data is data that exists in columns and rows and could sit within a traditional relational database. Semi-structured data means data that doesn't reside in a relational database, but that does have some organizational properties that make it easy to analyze, or easier to analyze, such as XML or JSON. And unstructured data encompasses everything else, such as emails or audio files. With current prevailing mass data storage tools, such as data warehouses, before we can load data, we first need to create tables and structures in that data warehouse to accommodate and create the relationships between data. We then need to extract data from sources, transform the data to match the format of the tables, and finally load it. When dealing with a data lake, the data can either be transformed into a certain format or simply loaded in its raw or native format from the data source. Some organizations we work with take advantage of the data lake's ability to handle raw data and use the lake as a staging area to load data prior to transforming it for downstream consumption. Other organizations use data lake folders to store copies of the data that already exists in structured database tables. The data lake can be used for either or both purposes, but crucially, it requires less formal processing. Data lakes are capable of storing data at relatively low costs as compared to traditional data storage solutions by virtue of the fact that the data lakes leverage open source software such as Hadoop and can sit on low-cost commodity hardware. They're also capable of handling a scale of data that dwarfs traditional data storage tools, running in the magnitude of anywhere from terabytes to petabytes worth of data. Given the relative lack of processing required to load data into a data lake and the low cost of storing and maintaining data in the lake, this enables the data lake to be more agile and meet business needs faster than many organizations are used to in this domain. Data sets in formats that could never previously be stored can now be loaded and then accessed for analysis with relative ease and speed. And finally, the data lake is an enablement tool that empowers data scientists and analysts within the organization, providing access to potentially all of the organization's data from one central location, with the ability to analyze cuts of data on an ad hoc basis. But it can also be used to mirror process data that exists in a data warehouse or used as a staging area before data is processed and then sent to a data warehouse or consumed by business users. Ultimately, just as there are varying reasons why an organization may look to adopt a data lake can play different roles within an architecture and different purposes for end consumers of that data, as we'll soon see. And with that, I'm going to pass it over to my colleague Ben to discuss specific case studies of data lake implementations.
Thanks, Alaistair. Now that we've seen what constitutes a data lake and addressed some of the common business drivers, we'll take a look at how those drivers materialize into some interesting case studies of data lake implementations. So the first case study I'd like to discuss derives from a property and casualty insurance company looking to leverage disparate types of data within a single architecture. Let's start, as with any design, by considering the drivers for adoption and pain points the company was seeking to alleviate. The organization desired an architecture and system that moved beyond a traditional data warehouse approach to provide a complete view of their customers, something that was flexible, agile, and incorporated new data sources that could provide new insights to analysts. This leads to the strongest driver from the case study, the need to have the scalability and resilience to add new data sources, whether that's traditional internal data or external data like a syndicated source, whether the data is structured, unstructured, or highly unstructured, and whether it's a strategic or tactical implementation. The organization required an approach that allowed new data sources to be seamlessly added without disrupting other data flows or business processes. There was also a need to have a flexible solution that could respond to changing user needs, which is a challenge with a traditional data warehouse approach. The last driver, among others impacting the design, was to leverage the cloud to handle analytics and processing. Specifically, this allowed the organization to use familiar analytical tools and minimize costs by using cloud storage. Looking at the comprehensive list of drivers, it is necessary to have an architecture that is able to bring sources of data together. So now that we consider some of the business objectives, let's take a look at what the architecture looks like. Here we have a simple diagram outlining the architecture. We start at the left with our raw data sources. The unstructured and highly unstructured streams are the ones being newly added to the organization's data portfolio and are married with traditional structured internal data. This cumulative data contains enormous amounts of raw and unstructured data in addition to enterprise data that's been cleansed, so the data lake needed to be designed to bring in those types and volumes of data. Access to various data sources aids in providing a complete view of the customer, which allows users to look through multiple lenses and join different data sets together. This design supports new sources being continually added without affecting other processes. Within the data lake, the unstructured data is stored in a file store, and the structured data is kept in a traditional relational store. An enrichment process employs cognitive analysis and transformations to add meaningful enhancements and refinements to raw data. Using modeling functions, common references and mappings are established independently in each of the stores and also between one another to create relationships allowing users to join up the data. Users access the data through a catalog where they can search for the information relative to their analyses and find what they need. An important and interesting piece I'd like to point out are the streams I've highlighted in green. The flexible architecture allows users to pull from a full data set, whether that's raw data directly from source, data from the stores, or the enriched and mapped data. This creates multitudes of combinations of data that can be leveraged in models and reports. Where a data warehouse is highly structured and stable, this data lake approach is agile, exposing users to data where they can continually configure and reconfigure their analyses and models. In this example, the entire process of storing large amounts of raw and structured data with enterprise information constitutes the data lake. So let's revisit the drivers and summarize how the architecture accomplished the business's objectives. The data lake solution provides a 360-degree view of existing and prospective customers. Users have access to data from sources in all different forms, whether it's raw or enriched. This allows them to discover insights that have never been considered. Various types of data were available to data scientists and analysts to perform their analyses and identify new trends. The marriage of enormous unstructured data volumes with enterprise cleansed data was key to the solution. By moving away from a traditional data warehouse approach, the data lake enabled the organization to store external and speculative data with the flexibility to quickly respond if that data became useful or new data sources were added. Lastly, cloud analytic and processing tools were employed as part of the data lake implementation. And this made storage of historical or speculative data cost-efficient and allowed different analytic tools to be used. Users could leverage enriched and raw data stored in the lake for their various analytic use cases. Next, let's take a look at a solution implemented for a healthcare and clinical research company. So for consideration of a data lake, one of the most important drivers for a solution was the ability to have robust external points of collaboration, both as inputs from various sources and as outputs to provide to customers. This required a flexible and scalable solution that adapts to the technologies and types of data provided by vendors and requested by customers. Tied to points of collaboration is the idea of cataloging data and setting standards, which helps to efficiently handle the data. Rather than creating something completely new and disjointed from other IT investments, it was important to design a solution built within an existing architecture, leveraging familiar tools. Ultimately, the organization wanted to make their data store less siloed, making it simpler for users to find and join data across disparate business segments with any tools they wanted to use. This approach ensured the investment had longevity to be interoperable with existing and future technologies. It was necessary to design a solution that stored data so it was accessible in ad hoc, one-off analyses, as well as more stable, process-structures similar to a data warehouse. By designing a consolidated data repository that isn't defined and siloed by a single business group, it creates a flexible and accessible data architecture that all users are able to pull from. Another important point was the need to improve and standardize data collection, beginning the process of moving toward a centralized data across the organization and distinctly away from a siloed data warehouse approach. Standardizing and centralizing data ensures a single version of the truth and reduces the need to replicate and store multiple copies of the same information. So let's move on to the architecture to see how the investment in a data lake has helped meet business needs. So here we have a depiction of the data lake architecture. Most vital to the design are the external points of collaboration. We'll start on the left-hand side, where a landing zone behaves as a data collection platform, welcoming different types of data from different sources. For this implementation, it's paramount that the data lake data capture mechanism coalesce with different technologies and procedures from vendor and third-party data sources to ensure customers' needs can efficiently be met. On the right-hand side, we have a collaboration point with customers, which are users that have access through an external interface to the appropriate data and reports. In the stable data storage and modeling structure on the lower portion of the diagram, this collaboration manifests itself in access to something like a Tableau or Click Server dashboard or application. So here, users provide the requirements and needs to be met by the company supplying the data via the lake. In the ad hoc upper portion of the storage and modeling segment, users have the power to do one-off analyses and exercises for any use cases that pop up. Here, users will employ analytic tools or self-service reporting tools for their analyses. This approach is an effective way to determine what data should be applied to a stable structure for more repeatable insights. The data lake, featuring data collaboration between numerous sources and consumers, facilitates the movement of data to and from vendors and customers. Together, the architecture creates a combination of repeatable and robust data insights one-off analyses, and various other use cases. We can see the dual storage and modeling tracks within the data lake environment, storing raw data in the ad hoc structure and enriched data in the stable structure. A strength of the design is the flexibility and agility to move data between the tracks to support customer needs of newly acquired sources or previously speculative sources. By designing a consolidated data repository that isn't defined and siloed by business group, it creates a flexible and accessible data architecture that all users are able to pull from. You can see if data suddenly needs to be enriched and applied to a Tableau server dashboard, it can be defined in a stable structure. Likewise, data that becomes more speculative or grows in volume can be moved to the ad hoc structure with lower cost, less processed storage until it's needed again. Tied to the consolidation of two distinct data tracks is the idea of cataloging data, models, and reports which supports customer demands. The architecture operates with a diverse set of communication and report tools. So let's wrap up this case study by highlighting some of the key takeaways. We'll quickly summarize how the architecture supported the business drivers of the healthcare and clinical research organization. The solution efficiently stored data by scaling to load information in any form from vendors and then hosted a collaboration point to provide data across tools to their customers. These points of collaboration allowed the organization to consolidate several disparate systems and data warehouses into a single process. The solution supported a diverse set of tools, whether they were source systems or reporting and analytic tools used by customers. This positioned the solution as a sustainable and interoperable IT investment working with a wide array of technologies. We saw in the architecture diagram, the design moved distinctly away from a traditional warehouse approach as it combines insights from ad hoc, raw, and stable data structures working in union with one another. This allows for the flexibility to move data based on where it was needed, whether required for a quick ad hoc analysis or to be in a more concrete structure. Lastly, the solution centralized data that had once been stored across multiple systems, which ensures a single version of the truth. It also set data standards and improved efficiency across a diverse set of data. So now that we've gone through a couple case studies to see how business drivers manifest into concrete solutions, let's tie things together by discussing some considerations and thoughts on how to get started with implementing a data lake. So we've walked through a couple case studies of data lake solutions. So let's think about what things are important to consider when thinking about implementing a data lake in your organization. First and foremost, as evidenced by our discussion today, is to identify and define the business drivers behind consideration for implementing a data lake. What are some of the use cases or business challenges that need to be solved? What type or types of data would you like to leverage? And is your current architecture limiting users or creating bottlenecks in analytics and reporting? It is necessary to have a strong business driver or drivers before considering investment in a data lake. It is certainly possible to start small, though, with a data lake, using a few data sources in a POC-like activity to understand how it fits into your architecture and understand any additional business drivers. A data lake needs to be flexible, able to bring data in and send data to various technologies, so it should work well with other technologies. You can pick the technology where experience lies and works with other technologies in your architecture, and one that's positioned to work with future and existing tools. The data lake should also be considered alongside other assets and initiatives to see where it fits into an existing architecture. For example, it may involve putting raw or enriched data into the lake that already exists in another repository. These are a few important things to consider when thinking about a data lake, and certainly a good place to begin contemplating the topic. If you'd like to learn more about any of the topics we discussed today, or understand how a data lake could fit into your existing architecture, we'd be happy to assist. Feel free to reach out to either Alaistair or myself if you have any questions about the content we presented or are curious on the topic. Here at Thorogood, we approach all projects in a way of balancing business goals and value with technical possibilities in order to achieve maximum potential for our clients. We help our customers with everything from implementations of individual solutions to how to get started with the tool, to developing enterprise-wide BI strategies and roadmaps, and many services in between. So it looks like we're just about out of time here. Our contact details can be seen on the screen now. Thank you very much for joining us, and have a great rest of your day.